All right, so this is going to be an example problem involving number theory. In this case, it says one positive integer is 5 more than the other. So that kind of gives us a hint right away that we are looking for two numbers that are basically positive, because it says one positive integer is 5 more than the other, and it's just assuming that the other is positive as well, just because it says the other, like the other positive integer. When the reciprocal of the larger number is subtracted from the reciprocal of the smaller, the result is 5/14. Find the two integers. Okay, so there's a lot of vocab here that we're going to kind of need to know. So it's kind of best to break down the problem, break down all the vocab that's in the problem first to kind of understand what's going on here. Okay, so first thing it says is one positive integer, so I'm going to kind of underline that. We need to know that this one positive integer, this one integer is positive. Okay, you need to know what an integer is. Integer just means any positive whole number, negative whole number, or zero, and then it's 5 more than the other. So first thing I'm going to do is actually make two of these integers. So I'm going to just say one is A and one is B. So those are my two positive integers that I'm looking for. If you notice at the end it says find the two integers. Okay, so we're going to ultimately be looking for A and B when doing this problem. When the reciprocal of the larger number, so reciprocal just means whatever it is, just flip the numerator and denominator. So in this case, the larger one, it would just be 1 over whatever one of these is, because this is going to be technically A over 1, and this is going to be B over 1. So the reciprocal would be 1 over A and 1 over B. And it's subtracted from each other, it should be equal to 5/14. So kind of let's break all this down. So this is the one positive integer is 5 more than the other, that first sentence. So basically what I'm going to do is I'm going to assign one of these to be 5 more than the other. In this case, I'm just going to do A plus 5 is equal to B. Now what this is going to essentially do is make one larger than the other. Okay, they're both positive, so if A was, let's just say A was 1, B would be 6 because you have to add 5 to it. So because of that, the B would actually be the larger one here, and the A would be the smaller one. So I'm going to write smaller here. Okay, that's smaller, and then B is the larger one. Okay, that second sentence says when the reciprocal of the larger number is subtracted from the reciprocal of the smaller. That means the reciprocal of the larger one, which is 1 over B, is subtracted from, so that means it's going to be subtracted from the reciprocal of the smaller one. So it's 1 over A minus 1 over B is equal to 5/14. So you end up with something like this. So basically you have a rational equation right here that you're trying to solve. The problem is we have two variables here, A and B, and you can never solve any equation if there are two variables. It's just impossible because there's infinitely many possibilities for these, for A and B. So what we're going to do instead is we have to make this where there's only one variable. Now to do that, we are going to substitute in the fact that B is equal to A plus 5. So really you're going to have 1 over A minus 1 over, now instead of this B right here, I'm going to put in A plus 5 because B is equal to A plus 5. So it's just going to be A plus 5 is equal to 5 over 14. So you end up with something like this. Now we have one variable. Now we can actually solve this right here for A, and then we have this A term right up here. And then all we have to do is take A and add 5, and then you have B. Okay, so that's what we're essentially going to do. We're going to solve for A here, add 5 to it, and then get B. You have to remember that they both have to be positive integers. So at the end, if we get a negative number, we have to kind of throw those out because you can only have a positive integer for the answer to this problem. So let's start solving this problem right here. This 1 over A minus 1 over A plus 5 is equal to 5/14. Okay, so the first thing I'm going to do is kind of rewrite it over here. So we're going to have 1 over A minus 1 over A plus 5 is equal to 5/14. Okay, first thing I'm going to need to do is make it so I have common denominators here. So as you can see, we don't have that right now because we have A as a denominator here and A plus 5. Now you can't just simply add 5 to this because that's just mathematically illegal. What we could do is multiply each of these by a special 1. Okay, a special 1, what I mean by that is I'm going to multiply this top part by A plus 5 and this bottom by A plus 5. This technically, in this green right here, A plus 5 over A plus 5 is equal to 1. So I'm not actually changing the value of this 1 over A. I'm just multiplying it by this 1. Okay, 1 times any numbers itself. So really, we're just going to get something that's equal to this 1 over A still by multiplying by A plus 5 and A plus 5. You would not get that if you just simply wrote a plus 5 in here. So you don't want to do that. Okay, this one, I want it to have the same denominator, which is the A times A plus 5. So I'm going to have to multiply this top by A and this bottom by A. You're going to kind of cram it in there. Okay, now we have common denominator, so now we can kind of just simplify everything. So this top part, it's A times 1 plus 5 times 1, so that would just be a plus 5 minus, okay, and then 1 times a over here is just going to be a. So that's just the numerators here. Now the denominator for this is all the same. It's all this a times a plus 5, a times a plus 5 right here. So it's just going to be this a squared plus 5a once you distribute a times a times 5. A squared plus 5a is equal to 5/14. Okay, let's simplify. We have this a minus a up top here. So what I'm going to do is just cancel these out. So it's a minus a right here. A minus a cancels out. You have 5 on the top and then a squared plus 5a on the bottom. So I'm going to kind of just rewrite this just to be a little neater. Plus 5a equals 5/14. Okay, now to solve this, I have to get rid of these denominators here. And the easiest way to get rid of the denominators is just to multiply both sides by the denominator. So if I multiply both sides by 14 here, this 14 and this 14 are going to cancel. But what you do to one side, you equally have to do to the other because of this equal sign right here. So I have to multiply this side by 14. Okay, now if you notice, this denominator is gone, but we still have this a squared plus 5a. So what I'm going to do is multiply both sides by a squared plus 5a. So now that's going to cancel. And then I'm going to multiply this side because, again, you equally have to do it because of this equal sign. A squared plus 5a. Okay, now it's canceled over here. Now you're just left with 14 times 5, which is going to be 70, is equal to 5 times a squared, which is 5a squared, plus 5 times 5a is 25a. So you end up with a problem that looks like this. Okay, you should notice that it's a quadratic equation. So to solve a quadratic equation, you can either factor it or you can use quadratic formula, or you can graph it. It's really up to you. So what I'm going to do first, though, is you have to have one of these sides equal to 0. So I'm going to subtract off 70 from both sides. So now you end up with 0 is equal to 5a squared plus 25a minus 70. Okay, I'm actually going to factor this one because it might be a little bit easier to do it that way. So the first thing I'm going to do is just factor out a 5 here. 0 is equal to 5, parentheses, a squared plus 5a minus 14. Okay, so now I have this nice quadratic right here. And what you can do is you can use the quadratic formula on this, or again, factor it kind of like what I said before. Now, since this leading term is a 1, we can kind of use the shortcut where we're looking for two numbers that multiply to get negative 14. So two numbers that multiply get negative 14 and add to get this 5. And those two numbers would be 7 and negative 2. So what I can do is rewrite this. So now that it says 5 times a plus 7 times quantity a minus 2. Okay, so now when you solve this, all you have to do is use zero product property. A plus 7 equals 0, and then a minus 2 is equal to 0. Okay, when you solve this right here, you get negative 7, and when you solve this, you get 2. Now, if you remember from the very beginning of the problem, you have to have an integer that's positive. So if that's the case, then you're not actually able to use this negative 7, but you can use this a equals 2. So we do know that a equals 2, so I'm going to kind of write that over here. So a is equal to 2, that's one of our positive integers. Now b is equal to a plus 5. So b is equal to a plus 5, and since a is 2, it's just going to be 2 plus 5. So that means that b is equal to 7. So let's find the two integers. That's essentially what we did. We have a equals 2 and b equals 7. So those are the two integers, 2 and 7, that make this entire thing true. Now what you're going to want to do is test this out. We already tested it out with this part right here, this a plus 5 equals b, but test it out with this. Is 1 over 2 minus 1 over 7 equal to 5 over 14? I would check that in your calculator, or you can do it by hand. Make sure you have common denominators, but in fact this 2 and 7 are correct. So that's basically the answer for this problem. So if you have any questions about anything in this video, let me know.